Hello everyone, this is Ahmed Al-Shimari. This is the first lecture in the GIS Desktop 10.x course. We will start from this lecture to explain the principles of geography, the principles of GIS, the principles that we will need to understand what is a GIS application and how can we use this knowledge to create our projects in our GIS Desktop applications. We will start from a simple point. We will start explaining the maps, the old maps and the new maps. To start from something very important, it is the coordinate system. So if we want to understand what is the meaning of coordinate system, we should look at this map, this old map. If we look at this map, we will see that it's represent some island. You can see these symbols. It represent the water. In the past, there is no coordinate system. There is no measurements of the distances. The maps used to show the routes and some objects on the earth. From this map you can see that there is some mountains in this area and this area. There are some trees or jungle in this location, and there are some type of rocks. It is just a rock, something like a rock. It's look like a human face. In the past, they use these maps to explain the shape of the earth, the proportional location of any objects. There is no distance, there is no units to measure the distance between any 2 points. We cannot find the area of this island. We cannot find the distance between this point and this point, or any two points. We just use this map to explain the shape of the island and how we can find some locations. The accuracy of these maps are very small because there is no coordinate system. Okay, now we will go to explain the new maps. In our days, the maps are containing from something we call a coordinate system. A coordinate system, it is a grid of longitudinal lines and latitude lines, long and lat. We use these lines, long and lat, to explain the position of any objects in the map. We can find the location of any objects. If we want to see the location of some objects, something like, I will enlarge this map. Okay, if I want to know the position of this object, some object in this location, I can read the number of the longitude line. This longitude line, the number is -95, and the latitude is 45. So I can say that this point coordinates is -95 longitude and +45 latitude. In this way, I can find the location of any point on this map by using the longitude and latitude lines. In this map, we can also find out the area of this map, the area of this location. It is the United States. I can find the area of this location approximately by looking to the scale bar. This is scale bar, I can use this scale bar to find the approximate distance between any points and the area of this location or this country. I can use it to understand the phenomenon of the map. In this map we are talking about something in this area, in this color. You can see this color. It is about electricity, I think so, kilowatt hour, square meter per day. In this area we have a value of more than 7.5, and if we're moving from this area to far, little bit far, we can see that the value of electricity it decreases to 6. In this color, you can see this color, it's 6 to 6.5. This color, it is actually this one. Okay, this color, yes, it is this one. Yes. Okay, you can see that from this map I can find the location, I can find the distances, I can find the area, I can understand the shape of the events or the sorry, the phenomenon. I can find the directions. I can see the distribution of my my events or my phenomenon. But if we think that this is a paper map, it is a paper map, we cannot put a lot of data in this map. Just a little bit data we can put it in the map, because it is a paper map. In GIS, no, it is different. You can put a huge size of data for a single map. You can use a lot of maps in one project. But now, if you see in this example, we see just one layer, maybe 2 or 3 layers, and a small size of data. We can use it in the paper maps. But in GIS, no, it is different. We will see this later. Okay, I hope you understand that the difference between old maps, it doesn't contain any coordinate system, and the new map, it is the coordinate system that I use to find the location, the size, the area, the shape of the objects. Okay. Let's say some simple example. If someone asks you to build a new house and he wants you to build the new house in a location, he said that longitude equal to 80 degree, latitude equal to 55 degree. You will take these coordinates, go to the field, and looking for the longitudinal line that represent the 80 degree and intersected with the latitude line that represented by 55 degree. In the point of intersection you should build the house. The same way, this is in the plan, the same way in the spherical. You just start from the origin. You start from the origin of the world and calculate an angular value equal to 80 degree from the origin to the positive side, or let's say to the east, because the longitude is positive. There is no negative sign here. Negative sign is not here. So we are going to the positive side. This angle represents the number of this longitudinal line. This longitudinal line has a number represented by the angle of this angle. After that, from this point we will calculate a 55 degree angle, and in the north, to the north, because it is positive also, latitude is positive also, we will calculate a 55 degree angle to reach to this point. This is the point that we should build our house. This is in a spherical and this is in the plan. you can use the same shape to this is an angular units. The angular units, degree millisecond, to used in a coordinate system. You can use the length units like meter, like mile, to find the locations on the earth. Let's say that all these numbers are in meter, for example. The longitudinal not represented in length units, the longitudinal not represented by the length of this line at the equator. This line, it is the equator. This line is the equator, and the longitudinal in meters are represented by the length of this section of the line of the equator, from the origin and the positive side and until this moment, this location, sorry. And the latitude are represented by the length of this line. It is the latitude, and this is the longitude. So if we have a degree millisecond coordinates, we will calculate the angles. But if we have a meter units, or miles, or kilometer, we will calculate the locations by measuring the distance on the equator, and then on the longitudinal lines to locate our points. The coordinate system that deal with degree millisecond units, we call them a geographic coordinate system, GCS. And the coordinate system that deal with meter, kilometer, or mile, we call them the projected coordinate system, BCS. Now we will explain what is the meaning of the coordinate system. This way we can use the coordinate system to locate the location, to find the location of objects on the earth. And now we are talking about the meaning of coordinate system and how can we make our coordinate system. Any coordinate system is used to find the location of the points. Before we get in the coordinate system meaning, we start from the explaining the different type of coordinates. We use, in the previous example, we use the long lat coordinates. This point, for example, it has a longitudinal equal to 90 degree. It is the longitudinal line number 90. Okay, the angle between the prime meridian and this longitudinal line, this angle equal to 90 degree. Okay, so we said that the longitudinal here is 90 degree. The latitude, longitude, and the latitude is 60 degree. Latitude, it is the angle between the equator and this latitude line. The angle between these two lines is equal to 60 degree. So we said that this point has a coordinates longitude equal to 90 degree and latitude equal to 60 degree. But we can explain these coordinates. We can use this type of coordinates. This type, it's depending on the XY system, the Cartesian coordinate system. X are represented by the equator. This is the origin, this is the positive X direction, and this is the negative X direction. Y represented by the prime meridian. This is the positive Y direction and this is the negative Y direction. So we can explain these coordinates by the XY type. We said that we have in X direction 90 degree, or we can use a meter, 90 meter, for example. So In this type, we said starting from the origin and moving 90 degree on the x positive direction, it's in this point. Then he said that y equal to 60 degree, it is positive 2, so I will go up until I reach the 60 degree. This is the second type. We can represent the coordinates of any point. This is the first type, and this is the second type. The third type, this is the third one. We can represent the coordinates by calling the direction and the value. He said 90 degree to the east. Okay, it's meaning I am standing at the origin and calculating 90 degree to the east. This is the east. This is the 90 degree to the east from the origin. And then 60 degree to the north, I am moving 60 degree to the north. This point, the same way, like the previous. Longitude, the number of the longitudinal line is 60 degree. You can see it here. Latitude, it's minus 30 degree. Minus 30 degree. Look with me. This is the origin. I will move to the 60 degree on longitudinal line. Then I will move minus 30 degree. 30 degree, it's mean I will go downstairs. I will go down until I reach this point. This is the minus mean. Okay, in XY coordinates, it is the same. Longitudinal represented by X axis, 60 degree in X direction. Okay, it is positive, so from the origin I will move in the positive direction, 60 degree. Then I move minus 30 degree in Y direction. It's mean I will go downstairs. Okay. The third type of the coordinate system, we will set to represent this point. We will move 60 degree to the east and 30 degree to the south. You can see that we are moving to the east, then to the north to reach this point. But in this point, we will move to the east, then moving to the south. The same way we can use it with these 2 points. It is the different representation of coordinates of any point. You may work with this type of coordinates. Sometimes you will see this type of coordinates, and sometimes we will use this type of coordinates. So you must understand every one of them. Okay. In the previous slide, we work with maps on a plane, but we can understand that the actual map of the Earth, it is not a plane, it is a spherical or ellipsoid, anything some shape like this, a 3D shape, not a 2-dimension shape. So how can we convert a spherical to a plane? It is a famous example. It is the orange crust. If we take the orange crust and try to convert it from spherical to a plane, we can see it's damaged and there are a lot of distortion happens to this surface. In coordinate system, we will get the same distortions when we work with the coordinate systems. We have a distortion in the measurements, the measurement of length, the measurement of width, area, volume of any objects in the map. Any object in the map will be distortion in the length, width, area, or volume. In the directions, yes, I have a distortion in the direction on any map when converting it from spherical shape to a plane shape. The third one, distortion, it is the shape. Yes, when I convert a spherical to a plane, all the objects in the map will be distortions in the shape, and we will see that in the next slides. Okay, the coordinate system, we can say that the coordinate system is starting from converting a uniform spherical or ellipsoid, a uniform it is very important word, uniform. It is very important, we will need this word later. A uniform spherical, convert it to a plan. This is the projection system. It is the part number 1 in the coordinate system. Every coordinate system depends on 2 parts. The first part is the projection system. Projection system of any coordinate system, it is mean the converting of the uniform spherical or ellipsoid to a plan map. This is the projection system. How can we do this? Okay, in the projection system there are three main methods. The first one is bi-cylindrical, the second one is conical, the third one is planar. In the cylindrical, we convert the spherical to a plan map by imagining this example. It is very simple idea. Let's assume that this is the Earth. It is something, the surface of the Earth is something like a glass, transparent, something transparent, so the light can go through this surface. If we draw the map of the world on this sphere, and turn on this light inside the sphere, we will see the world map in the internal faces of this cylinder. I hope you can imagine this experiment. When we draw the map in the internal faces of this cylinder, we just cut one side of this cylinder. When we open the cylinder, we will get the plan map. This is this experiment are shown in this figure. Okay, this is the spherical, cylindrical projection system. Cylindrical. We will convert the spherical of the Earth to a plane map. In this projection, you can see very important points. First one, look at this island. This is the Iceland. In the Earth, it is a small island, but after projecting the map, we will see that this island is more bigger. Why? Because there are a distortion in the shape. Actually, the distortion in this type of a projection, the distortion, it is minimum at the equator, and any location near from the equator there was a small distortion. But near from the North Polar and the South Polar, no, the distortion will be a huge amount, very big. You can see that the South Polar, it is very small area in the Earth, but after projecting, you can see it is a huge land. It is its area maybe looks like more than the area of Africa. You can see that, if you can imagine that this area more than the area of Africa, but in the real world, no, it is very small. It's smaller than Africa. This is the cylindrical projection type. We have another type, the conical. We use a conical instead of a cylindrical, and use the same experiment that we explained previously. We use the same one, but now we will get a map in this shape, like a triangular with an arc in the base, this curve in the base. In this type, we will take approximately not the whole world, just a half of the world, the half of the Earth we can project on this type of projection. You can see this, and if we assume that this line on the Earth, it is the line where the conical attached the Earth. So in this line the accuracy, you can see it is this is the same line, this is the same line. The accuracy in this line and the locations near from this line, it is high accuracy, had a high accuracy, but in this area or this locations at the edge, no, the accuracy will be small and distortion will increase at the edge. The third type of projection, it is the planar projection. We use the same idea, but now we just use a plan, circular plan, like you can see it like this. And to draw the map, we can put this plan, this circle, anywhere in the earth and turn on the light, draw the map, and we will get a map in a circle like this. This is the type of this projection. This is an example. If you want to draw the North Polar, just put your circle at the North Polar, turn on the light and draw the map. The accuracy is high in this location from the center, but it is the distortion is very high at the edge. Okay, this is the projection system. The projection system that we will use to convert a spherical or ellipsoid to a plan map. Okay, this is the first part of any coordinate system, a projection system. Now we will take some example of a projection system that can be used. If we imagine that this is the Earth, and we imagine just look at this location, this part, this zone. It is in the Middle East. If we draw two circles equal in radius in this location and another circle with the same size, the same radius in this location here, and take this triangle on the earth, draw this triangle on the earth. So when we convert this earth spherical or ellipsoid, when convert this to a plan map using a GCS coordinate system, we can see something like the first circle stay in the same size approximately and same radius, same shape. Can you see it? Yes. But the north one, the top, the circle on the top, we can see that it is become bigger, more bigger, increase in the horizontal radius and increase more in the vertical radius. Why is that happened? Because the GCS system, it is a cylindrical projection. It converts the whole world in a rectangle. It just, you can see this edge actually, this is the same edge. This is the same edge, and this another one, this edge, it is this here. The GCS just open this triangle from the head, open it to make the distance in this location same as this distance. So you can now understand that this circle will be increased in the horizontal radius and will increase in the vertical radius. The coordinate, the origin of this projection system, the origin, it's the same one here in this location, this one. Okay, it is constant for the whole the world. All the world are in this origin when we use a GCS coordinate system. But if we use a UTM coordinate system, in UTM coordinate system, Mercator, it take just this zone, it take this zone only and convert it to a plan map. So in this coordinate system, in this projection, or in this method, we will keep the shape of the triangle as a triangle, but it will be, there are some distortion in the north circle, but it is less than the distortion in the first type in the GCS coordinate system. This happened, why? Because the UTM just try to keep the triangular shape of this zone as a triangular, but it still has some distortion in the top, in the north. But near from the equator, the circle is the same as the circle on the earth. The origin in this coordinate system, the origin, it is always at this corner, and this is the x, positive x, and this is the positive y. This is the positive y. Okay, GCS, there are one origin in the world for the all map. It is here in this one, but in UTM, no. Every zone has an origin. This origin lie on this corner at the base of the zone. The left corner on the zone. Okay, there are another projection coordinate, projection system. This is the GCS projection, this is the UTM projection, and this is the CODIS homosaline. It is the same way, if you can remember this shape. It is the same like the example of orange. I hope you remember it. Yes, this one. Okay, it is this shape. It is approximately the same as this shape. The idea of this projection is make some cuts, some cutting the surface of the earth. Sorry, the surface of the earth, cutting in some places and open it. There are a similarity between this coordinate, the projection system, and the UTM projection system. It is all as a triangle, all section as triangles. In this projection system, you can see we keep the shape of the triangle. Okay, it is inclined. It is not, this triangle is straight, but here we can see that this triangle is inclined, and we can see that the circles at the bottom and the top are approximately the same as the original circles. This projection type keeps the shape of the map, same way the Robinson projection, it's look like the same as previous one. It's keep the shape of the objects on the map. You can see that the same triangle, inclined triangle, the same one here, you can see it in the same shape here. Also the circles remain in the same shape. So we can understand that the coordinate system, starting from projecting a spherical or ellipsoid and make it like a plan map. But the problem is we are talking about a uniform spherical, uniform ellipsoid. No, the actual shape of the earth, it is not uniform. The second part of any coordinate system called the datum. We understand now coordinate system is first part of it. It is the projection system. The second part, it is the datum. What is the shape of the earth? This question can be answered by the geodesy or the geodetic system. The geodetic system is some science that trying to understand the actual shape of the earth, the sea, and the gravity field. From these all, we can take them and convert them to the best uniform spherical or ellipsoid to the earth. So the geodetic system just convert the actual shape of the earth. You can see now this is the actual shape of the earth. The geodetic system convert this to the most accurate uniform ellipsoid or spherical shape to the earth. This is the geodetic system, or we called it sometimes the datum. Okay, we have many types of datum. In Iraq we use the Clark 1880. Sometimes I saw some shape files, it's not 1927, and now we are using the WGS 1984. This is the newest one. This one is depending on satellite reading to the Earth, and they produce this actual shape of the Earth. Then they use the computers to convert this shape to the best ellipsoid can represent the Earth. This is the geodetic system. So we have, in any coordinate system, we are using two parts. One part to the geodetic system to convert the actual Earth, the actual shape of the Earth, to the ellipsoid, uniform shape. Then we take the uniform shape and convert it to a plan by a projection system. I hope this drawing will be very simple. We use the geodetic system to convert the actual shape, not uniform shape, of the Earth to a uniform shape. Then we use this uniform shape in the projection system. We use this uniform shape to produce the two-dimension map. This is the geodetic system and this is the projection system, and both of them representing the coordinate system. We should understand this. When we use any coordinate system, we should understand what geodetic system we are using and what a projection system we are using. It is a simple example about the difference in coordinate system. Let's say that I am in Iraq. I send to you the coordinates of my house, so when you come to Iraq you can visit me. I send to you the x-axis and the y coordinate, my x and y coordinates of my house. But I use a map in NAD 27 geodetic system. My datum is NAD 27. But when I send these coordinates to you, I don't tell you that this is my geodetic system, this is my datum. So you just take my coordinates, use your GPS and input these coordinates that I sent it to you. When you see the location of my house, you will be a little bit surprised, because I told you I am living in Baghdad, in this area. But now when you put my coordinates in your GPS, you will find that my house is in this location. This is not Baghdad. Baghdad is just here. You will call me, you will ask me, these coordinates are not correct. I will tell you, no, it is correct, and your GPS is not correct. And but when we understand what is the meaning of the datum, you must ask me what the datum of your map when you read your coordinates. If I told you it is not 27, then you have to use a map of the same datum to project my house. This is the simplest method or way. I think this will help you to understand what is the meaning of the coordinate system, how can we use the coordinate system to locate any points. Okay, now we are going to explain another subject in GIS. The second important subject we must understand before we get in GIS applications, it is the GIS data. If you have any experience in databases, you can understand this subject easily. GIS data, there are two parts in GIS data. Spatial data. Spatial data, it is the images, satellite images or paper maps when we put it in the scanner and convert it to an image in our computers, and the maps that we draw in the GIS applications. This is the vector data. They are just something like a maps, but they are a vector data. Okay, all of these are spatial data. The images, satellite image, it is a raster data, and the maps, it is a vector data. When we go into ArcMap, I will explain what is the difference between vector data and raster data, but in this moment we have to understand just that the raster data it take a large size on memory, but the vector data take a small size in memory, very small size in memory. The vector data are connected to the tables. Connection between vector data and tables are very strong and very useful, but between raster data and tables there are some kinds of connections, but not like the vector data and tables. This is the spatial data. Spatial data just give me the shape of the object, the location of the object, the size of the object. This is all in spatial data. I can read it from maps, vector data, or from satellite image, or from raster map. The second type of data in GIS, it is the attribute data, the data that arranged in tables. Okay, these tables may be DBF files, Excel files, Access, SQL Server, Oracle, or any database application files. I can connect these tables to the project and use these data on my maps. I can use a huge size of data, attribute data. Actually, even I can use a huge size of maps, spatial data, and make very large projects. I have a dynamic methods, dynamic tools. I can use a lot of tools in ArcGIS to produce very correct and very interesting, and I don't know what is the English word, something very clear, obviously, I don't know the English word, sorry. But in ArcGIS I can draw maps, a lot of maps, in a fast time and a simple way, as we will see when we reach the ArcMap and the editors in ArcMap. This is the GIS data in GIS. GIS data is spatial data and attribute data. Tables are sometimes connected to the vector data, and I can connect to any database, connect from my project to any database and store the data that I need. In ArcMap, one of the ArcGIS desktop applications, we are working with the maps, vector data or raster data as layers. So you can imagine that we have some layers, 1 over 1 in the bottom, and some layers after it. If we look from this side, you will see this layer, and you can see from the areas between these lines, you can see the next layer, and sometimes in these empty regions you can see the next layer and the next layer and the next layer. At the end it is the satellite image. So in ArcGIS, when you use the layers, we start always from putting the point layers, the layers that are represented by points in the top, and the layers represented by lines in the middle. After them, the layers that are represented by polygons. At the end, we put the images. We can change this order as we need. It is very simple. We can remove any layer. We can add how much layer we need. We can add data from tables as much as we need. It is very simple and very useful. We can produce a lot of kinds of maps as we need, and something we can use it efficiently. In attribute tables, before we get in the attribute tables and designing of the attribute tables, we need to know the data types that can be used in attribute tables. The first type, it is short integer, and this is the range of this number. If we choose a field in a table with short integer, we can put numbers from minus 32,768 to 32,767. If we choose a long integer type, we can use a range from this number. It is minus 2,147,483,648. Sorry, my English is not very good. And from this number to this number. I hope you can read it. These two types of fields, of data types, they are integer. They don't accept any point. There is no point in this numbers, just integer. I can't, if I have a number like 5.6, I can't not use this type or this type. If I a number with points, I need to use this type or this one. For this type float, it is a number from minus 3.4 exponential 38 to 1.2 exponential 38. The double type, it is a number from minus 2.2 exponential 308 to 1.8 exponential 308. This is the float and this is the double. These two numbers can accept points. The text type, which is used to input text, something like words, titles, names. In default, when we create this field, we will use 50 characters. We can use 50 characters, but we can increase this number, I think, to 256 characters maximum, I thought, something like this. I'm not sure, sorry. And the date, we can use fields with the date data type. This date is month and day and year, hour, minute, second, AM or PM. We have two fields. In ArcGIS shapefiles and feature classes, maps. In maps, we have two fields. In the tables of ArcGIS, we cannot use them or editing them. The first one, it is the object ID or feature ID. This is representing the connection between the table and the vector data, vector layer. There are a connection between any table and vector layer, between a vector layer and the table. This connection made by the feature ID. It is auto increment field, and used to make the connection between the vector layer and its table. Geometry field, it represents the shape of the shape that can be drawn in the vector map, in the maps. We cannot use these two fields in any editing tools, or we cannot change them. Okay, I hope this is clear. This is the data types that can we use with the tables, in ArcGIS application. Now we reach to the most important things to explain in GIS. What is GIS? We speak about mouse, we said something about coordinate system, we said something about layers, we said about vector data, raster data, but what is the meaning of GIS? Really, what is the meaning of GIS? The meaning of GIS, or the efficiency of GIS, I think my English is correct. It is the connection between a vector layer and its table. Every vector layer has a table. the connection between the vector layer and the table by a field called FID. You can see that this feature has an feature ID equal to 9171. If we go to the table of this shapefile or this vector layer, you will see that there is an FID like this, 9171, and this is the shape or the geometry field. You can see it is a polyline, okay, and this is the data. In this record all the data, and this record distributing the attributes of this feature. We can add another fields to add another properties of this line as we need. Okay, this is the meaning of GIS. It is just a new geodatabase, a new database that can be contain spatial data with attribute data in the same window or in the same application. You can connect them very simply. The connection is always available to connect the attribute data with the spatial data. Okay, this is the meaning of GIS. You have to understand this idea. You have to understand the meaning of coordinate system. You have to understand the meaning of GIS data. It is very important to go and learn the ArcGIS desktop application. The application of ArcGIS desktop starting from the program ArcMap. ArcMap, it is a very wonderful program. You can use it to draw your maps. As you see now, I use it to draw this map, this city map. I have layers, this map containing from many layers, Zuhur houses, surfaces points, surface lines, surfaces, Iceland, asphalt, streets, all, and satellite image. There are all just layers, and the order of these layers in this location, in this window, are the top layer here. It is a top layer in this data view. This is the data view, and this is the table of contents. The top layer here, it is the top one here. The last one, the last layer here, it is the last one, will be at the end or in the back of all these layers, in the back. You have to understand that the order of layers here is the same order in the data view. We use ArcMap to draw the maps, to input data, to make our processing tools, to project new maps, and it is the main program actually. ArcMap, it is the main program in ArcGIS desktop application. The second program, it is ArcCatalog. We use ArcCatalog to create the files that will be used in our projection. We use ArcCatalog to create our files. First of all, in all of our projects, we should create one folder to our projects. Inside this folder, I think it is a good idea to create some folders, one to the vector data, one for the image, one for the tables, and another folder if we have anything or data sources, more than data sources. Inside the vector data folder, we put our maps that we will draw in GIS. In this folder, we will put the satellite image. If we have any maps, map raster maps, we can put them in this folder. And if we have any other resources, tables, databases, we can put them in this folder. The MXD file, this MXD file, it is the ArcMap file. We can see the maps, we can edit the maps from this file. When you double click on this file, you will see the ArcMap window. And we said before that the ArcMap, it is the main application in ArcGIS desktop. When we work with ArcMap and finishing our work, when go to save, actually we are going to save this file, the MXD file. This file, MXD file, will need all these folders to show us this map. This file need all these folders to show the map to us. This file contain only the path of the layers, the satellite images, and the database connections. Just contain the addresses, but the data, the maps, the tables, actually not in MXD file. They are all in this folder. So when you send your work, when you finish your project and you want to send it to someone, you should send the MXD file with these folders. MXD files alone will not work, will be not enough. You should send all these files. Okay, now we will go to explain the ARC catalog and ARC map programs in ArcGIS Desktop. I understand that my English is not very good. I hope you understand me in this lecture. The most important point to me, it is to understand that any coordinate system is represented by two parts: the geodetic system, or the datum that convert the uniform shape of the earth to a uniform shape, and the projection system that convert the uniform shape, the uniform spherical or ellipsoid, to a two-dimension map. This is the important thing. You have to understand what is the coordinate system and how to use coordinate system, and understanding if there are some errors happens, how to solve these problems. Thank you for listening. Sorry for my English. It is a difficult subject, and I don't know how to explain it in other ways. Thank you for listening. I hope you understand me. See you in the next lecture. Goodbye.